My name is Sophie Kornfeld. Today is October 21st, 2024, and I have chose to do my presentation on the feedback loops in non-gravid female reproductive system. So the hormonal control of reproduction in both sexes is based on the basic hypothalamus anterior pituitary peripheral gland pattern. Gonadotropin releasing hormone, GnRH, from the hypothalamus controls secretions of two anterior pituitary hormones, follicular stimulating hormone, or FSH, and luteinizing hormone, LH. FSH and LH in turn act on gonads. FSH, along with steroid sex hormones, is required to initiate and maintain gametogenesis. LH acts primarily on endocrine cells, stimulating production of the steroid sex hormones. In recent years, physiologists have determined that the control of GnRH is under the control of hypothalamic neuropeptides, including kisspeptin. Although the primary control of gonadal function arises in the brain, they also have their own function. Ovaries secrete peptide hormones that feedback to act directly on the pituitary. Inhibins inhibit FSH secretion and related peptides, and activins stimulate FSH secretion. Activins also promote oocyte maturation and development of embryonic nervous system. On the right, you will see an image that shows the hypothalamus connecting to both the anterior and the posterior pituitary. You can see how the hormones would be able to travel down and all interact together. Next is gonadal hormones, which are produced in the gonads. So in this case, it would be ovaries for the female reproductive system. The main gonadal hormones in females include estrogen, progesterone, and androgens. These hormones feedback to alter secretion of GnRH, FSH, and LH in a long loop response. So when circulating levels of gonadal steroids are low, the pituitary secretes FSH and LH. As steroid secretion increases, the negative feedback usually inhibits gonadotropin release. Androgens always maintain negative feedback on gonadotropin release. As androgen levels go up, FSH and LH secretion decreases. Estrogen can be a little bit more complicated, though. Higher concentrations of estrogen can exert a negative or a positive feedback. Low levels of estrogen have no effect on the feedback. Moderate concentrations of estrogen have a negative feedback effect. But if estrogen rises rapidly to a threshold level and remains high for at least 36 hours, feedback switches from a negative feedback to a positive feedback, and gonadotropin release, particularly luteinizing hormone, is stimulated. The paradoxical effects of estrogen on gonadotropin release play a significant role in the female reproductive cycle. They're not sure the mechanism behind the change between the negative and the positive feedback, but it could be mediated through the kisspeptin secretion again. On the left, you just see a basic diagram of the female reproductive system, which you can see the ovaries right here, which is where we're discussing. So next, we're going to focus on the menstrual cycle. Feedback loops are important in maintenance of the menstrual cycle in non-gravid or non-pregnant females. So I'm going to start with the follicular phase and then work my way through ovulation and the luteal phases. So just before the beginning of each cycle, the gonadotropin secretion from the anterior pituitary increases. Under the influence of FSH, a group of tertiary follicles in the ovaries begin to mature. As the follicles grow, their granulosa cells, which is under the influence of FSH, and their thecal cells, which is under the influence of LH, start to produce steroid hormones. Granulosa cells also begin to secrete AMH. This AMH decreases follicle sensitivity to FSH, which prevents recruitment of additional follicles once a group has already started developing, so you can only have one developing follicle. Thecal cells synthesize androgens that diffuse into the neighboring granulosa cells, where aromatase converts them to estrogen. Gradually increasing estrogen levels in the circulation has several effects. First, the estrogen excretes a negative feedback on the pituitary FSH and LH secretion, which prevents the development of additional follicles in the same cycle. At the same time, the estrogen stimulates additional estrogen production by the granulosa cells. This positive feedback loop allows the follicles to continue estrogen production even though FSH and LH levels have decreased. In the uterus, menstruation ends during the early follicular phase. Under the influence of estrogen from developing follicles, the endometrium begins to grow or proliferate in preparation for pregnancy. This period is characterized by an increase in cell number and enhanced blood supply to bring nutrients and oxygen to the thickening endometrium. As the follicular phase ends, ovarian estrogen secretion peaks. By this point in the cycle, only one follicle is still developing. As the follicular phase ends, granulosa cells of the dominant follicle begin to secrete inhibin and progesterone in addition to estrogen. Estrogen, which has exerted a negative feedback on GnRH earlier in the follicular phase, changes to a positive feedback, leading to a pre-ovulatory GnRH surge. Immediately before ovulation, the persistently high levels of estrogen, aided by the rising levels of progesterone, enhance pituitary responsiveness to GnRH. As a result, LH secretion increases dramatically in a phenomenon known as LH surge. FSH surge is also present, but to a lesser degree, probably because it's being suppressed by inhibin and estrogen. The LH surge is an essential part of ovulation because it triggers the secretion of numerous chemicals that are necessary for the final egg maturation. Meiosis will resume in the developing follicle within the first meiotic division. This step includes the primary oocyte into the step divides the primary oocyte into the secondary oocyte and into the first polar body, which will disintegrate. While this division is taking place, antral fluid will collect and the follicle will grow to its greatest size in preparation to release the egg. And then the high levels of estrogen in the late follicular phase prepare the uterus for possible pregnancy. Then there is the ovulation stage. At about 16 to 24 hours after the LH peaks, ovulation will occur. The mature follicle secretes prostaglandins and proteolytic enzymes such as matrix metalloproteinases, or MMPs, that dissolve collagen and other components of connective tissue holding follicular cells together. The prostaglandins may contribute to the follicle wall rupturing at its weakest point. The antral fluid will spurt out along with the egg, which is surrounded by 2 to 3 layers of granulosa cells. And then the egg will be swept into the fallopian tube and carried away to be fertilized or die. And finally, the last stage of the menstrual cycle is the luteal phase. After ovulation, follicular thecal cells migrate into the antral space, mingling with the former granulosa cells and filling the cavity. Both cell types then transform the luteal cells of the corpus luteum. The newly formed luteal cells accumulate lipid droplets and glycogen granules in their cytoplasm and begin to secrete hormones. As the luteal phase progresses, the corpus luteum produces steadily increasing amounts of progesterone, estrogen, and inhibin. Progesterone is a dominant hormone of the luteal phase. Estrogen synthesis diminishes initially, but then will increase. However, estrogen levels never reach the peak seen before ovulation. Combination of estrogen and progesterone exerts a negative feedback on the hypothalamus and the anterior pituitary. Gonadotropin secretion, further suppressed by luteal inhibin production, remains shut down through most of the luteal phase. And then under the influence of progesterone, the endometrium continues its preparation for pregnancy and becomes a secretory structure. Endometrial glands coil and additional blood vessels grow into the connective tissue layer. Endometrial cells deposit lipids and glycogen in their cytoplasm. These deposits will provide nourishment for the developing embryo while the placenta fetal-maternal connection is still developing. Progesterone will also cause the cervical mucus to thicken. This mucus can create a plug that blocks the cervical opening, preventing bacteria as well as sperm from entering the uterus. The corpus luteum only has a lifespan of about 12 days. So if pregnancy does not occur, the corpus luteum will undergo apoptosis. And then as the luteal cells degenerate, the progesterone and estrogen production will decrease. This fall removes the negative feedback signal to the pituitary and hypothalamus, so secretion of FSH and LH increases. The remnants of the corpus luteum become the corpus albicans. Maintenance of a secretory endometrium depends on the presence of progesterone. When the corpus luteum degenerates and hormone production decreases, the blood vessels in the surface layer of the endometrium contract. And without oxygen and nutrients, the surface cells will die. And then about 2 days after the corpus luteum ceases to function, or 14 days after the ovulation, the endometrium begins to slough off its layers and menstruation will begin. Menstruation usually continues for like 3 to 7 days and goes back into the follicular phase of the next ovulation cycle. And so you can see on the right just the transition through all the phases. You can see the follicular phase, then ovulation, the luteal phase, which focuses on the follicles. And then at the bottom, you can see the phases that the endometrium goes through as it goes through. And those are all mediated by hormones and feedback loops. And finally, this is a summary slide of everything we discussed regarding the menstrual cycle. And it shows the hormones and the role they each play. And this concludes my presentation on the feedback loops and the non-gravid female reproductive system. Thank you.